algebra students, Mr. Lawrence here. Who else would it be? And we are going to have mouse troubles apparently. Move! I say move! It's not moving for me. Let me see if I can fix it. Okay, I think we're fixed. We've graphed functions like 3x plus 1, and I know Kane could tell me, well, geez, Mr. Lawrence, that's a linear function. I'll say, what does that mean? He'll go, it's going to make a line. Absolutely. And I think Alyssa could tell me that this is a quadratic, and it'll make a parabola. What will happen with a function like this? This is called an exponential function because the variable is an exponent, exponential. And I got to tell you, this thing is going to grow really quick. You know, when I was a kid, there was a shampoo commercial, and it said, if you know the secret and you tell 2 friends, okay, and then they tell 2 friends, and then they tell 2 friends. Look at how quickly this is growing. Okay, there haven't been that many tellings, and now look, they're going to tell 2 friends. Okay, look at all these people. What am I going to do? There's not a friend in my house. I gotta get some extra space because they're going to tell 2 friends. And look at that. Look at all those people that know. Okay, look at how massive this is getting. And then they, must have pressed a button accidentally. Sorry. What the heck is going on? There we go. They tell 2 friends. And it must be too much. It's taking way too long. I'm getting too much lag. And then they tell 2 friends. And they tell 2 friends. And if it was working right, it would be doubling and doubling and doubling and doubling, but it's not doing it. But anyway, let's go back. There we go. Just a little bit of lag there. And let's take a look at this equation again. Oh my goodness, I'm having all sorts of trouble. Because that means I'm not supposed to do a video. I can take the break. Okay, I'm back. So let's take a look at like an input-output table for this exponential function. And you should see really quickly that when x is 1, 2, 3, 4, 5, 6, this is going to start to grow really quick. Okay, when x is 1, y is going to be 2. When x is 2, it's 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Somebody's got me. I can't. It's out of control. 4096. Oh my gosh. I don't know what to do. I'm going to be up in the 8,000s already, right? It was going to be what? 8192, I believe, right? And then 16384. Oh my gosh. Look at this sucker. It's just taking off. And then 32,768. It's just doubling. It's getting huge. All right. So this puppy is going to take off quickly. Let's go ahead and try to graph it and see if we can't figure out what's going on. Yep, there, we're back to misbehaving. It just doesn't like this page. Maybe I should just delete this page with all these people. Does that make me a murderer? Like I'm... Okay, hopefully getting rid of that page with all that extra data in it will fix things out. Now, here's my input-output table for y equals 2 to the power x. And we know that's 2, 4, and 8. What happens when 2 is raised to the 0 power? Well, any non-zero number raised to the 0 power, I know Maddie knows, is 1. Right? So I'm going to have 0, 1 is going to be on my graph. 1, 2 is going to be on my graph. 2, 4 is going to be on my graph. And notice the doubling, see? Went up 1, now it went up 2. This one's going to go up 4. Okay? And so part of my graph is going to look like this. It's not a parabola. It's not half a parabola. It's exponential. It's growing differently than a parabola would. And notice I didn't go all the way over to where x is 4 because that's going to be way up at 16. It's going to be up here somewhere. Okay, but what happens when I get below 0? Well, 2 to the negative first, you should recall, is 1/2. Negative exponent means use the stairs. Okay, 2 to the negative second will be 1/4. and then 1/8. So we're going to have 1/2, 1/4, 1/8. And so the rest of the graph is going to do something like this. And it's going to get down really close to the x-axis. I'm wondering, can you tell me how close to the x-axis it'll get? I mean, if I go the other way and go, well, 1/8 and then 1/16, right? And 1/32 and 1/64 and 1/28. Oh no, it's starting again. And 1/256 and 1/512. When will that get to 0? Hopefully you realize it'll never get to 0. This graph will never touch the x-axis. There's going to be an asymptote there, an imaginary line. Some of this I know is review. We're setting up for what we're going to do in a couple days. All right, so there's going to be an asymptote for the x-axis, and the graph's going to look like that. I used my graphing calculator to get a nice pretty image here of y equals 2 to the power x. And I wanted to show you what happens as I go along the curve. So you see here I'm at x is negative 1.489362, and y is at 0.3. And now I'm up at x is negative 3.8. Now it sure looks like on the picture it's on the x-axis, but it's not. It's not. Okay, and to prove to you it's not, let's see if the graphing calculator will let me do this. I'm going to make a z-box, and I'm going to blow up. Oops. Hold on a second. Graph. Zoom 6. Okay. And trace. Okay, and now I'm going to do a z-box. 1. And what a z-box is going to do is blow up the part of the graph I want to examine what's happening. So I'm going to kind of put a rectangle around the x-axis. I'm not positive if this graphing calculator is sophisticated enough to show you what's going to happen. Well, let's give it a shot and see what happens. Ooh, look. And so now I can hit trace. And see, it's not really on the x-axis. See how there's this kind of thicker line? It's getting closer. It's not actually a line, it's a curve. So you see it's not actually on the x-axis. Now what happens is the calculator is not sophisticated enough to really interpret, but you notice it looks like it's on the y-axis or the x-axis, but look at the y-coordinate. It's not 0, is it? No. And if I wanted to, I could do a zoom. I could zoom in right there. And hit trace. And it looks like I'm on the y-axis, but I'm not. Or excuse me, it looks like I'm on the x-axis. I'm not. I'm just a hair above it. So much so that the eye can't even tell. And look, I'm still not getting to 0. And some of you are thinking, geez, I want to get to 0. Now I'm in pretty small scientific notation numbers. Yes, but they're not exactly 0. All right, I've got to pause here and finish this video up in a few minutes because you lovely students are coming to see me. Okay, did you miss me? I'm back. All right, we're going to do one more here. Oh, I lost the equation. Perhaps it's on that one and I scrolled it down. Ah, there it is. Okay, I've got 2 to the negative x. Well, we just have to be careful when we fill out our input-output table here. 2 to the negative 0. No such thing as negative 0. It's just going to be 1. 2 to the negative first. Well, 2 to the first is 1/2. Is 1. Excuse me, is 2. So 2 to the negative first will be 1/2. So this will be 1/4. This will be 1/8. Okay. If I put a negative 1 in for x, I'm going to get 2 to the negative first, which would be 2 to the first. 2 to the negative second, when x is negative, will give me a 4, and then of course an 8. So it's actually going to be kind of like a mirror image. 0, 1, and then let me see, negative 1 is going to be at 2, negative 2 is going to be at 4, negative 3 is going to be up here at 8, and then we're going to have 1/2, 1/4, and 1/16. 1/8, 1/16, 1/32, and then it's just going to do this. Now I'm not going to go into it right now, but I have a question for you. Oh, by the way, there will be an asymptote there. What is going to happen, excuse me, if my equation, say, is y equals negative 2 to the x power, and what is going to happen if I have a y equals to the x, say minus 3. See if you can figure out what's going to happen and tell me tomorrow in class. All right, Mr. Lawrence signing off. Have a good night, everybody.